Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, Dave Ansell and Chris Smith. Now, Matt has asked, is it true that there are more babies being born than there are people dying of natural causes?
I think in the world, certainly, because the population of the Earth is growing quite fast. We've just passed 6 billion now, and
Crikey.
And it's definitely going to be hitting 10 billion very soon. In the UK, though, I'm not sure it's true, because I think for every woman there's less than 2 children being born, so the sort of natural growth of the UK population isn't going to keep up with people dying, so the population is going to shrink. And I think the population is being kept up by immigrants, but the actual number of people being born isn't more than the people dying in the UK. About you, Chris? Any?
Yeah, you're spot on the nail there, Dave. The number of people who die in the UK every year is about 600,000, and the number of new babies born every year in the UK is about 600,000. But that doesn't mean the population's static, for 2 reasons. One is that certain subsets of the population are growing whilst others are shrinking, so there are more babies being born to certain members of the population and certain social classes in the population. And also, as Dave says, there are quite a few people flocking to the English coastline in order to do work here, because obviously they can earn more here than they can in other members of the parts of the EU. So immigration is making a big difference to our population. We're now up to about 60 million people in the UK. We had about 56 million till recently. That number's gone up quite a lot. On a global scale, there's 6.3 billion people on Earth now and counting. We hit the 6 billion mark about 5 years ago, but of course there's going to be a big lag between real numbers and actually what we think the statistics are. So probably the numbers are far more than 6.3 billion now. And India hit 1 billion people in the year 2000. So yes, within the next few years, we're very quickly going to hit, as Dave says, probably the 10 billion mark. But then the question really comes to how many people can Earth actually sustain? Because it all comes down to resources. And if you look at how much energy we're burning off in the West, we actually need 2.5 planet Earth's worth of resources in order to supply the kind of lifestyle that we have in Western countries. And if you add into that equation all the people that don't live in Western countries, who live in places like China, places like Africa, if they start having the same lifestyle that we have here at the moment, then the Earth will completely fall to its knees. So this is why people are quite eager to try and find some kind of solution, which will mean that we can continue to enjoy a high standard of living, but perhaps not quite as decadent or as wasteful with our resources as we have been in the past.
And of course, every so often there is a kind of Mother Nature cull, isn't there, because we have some epidemic of some description that we used to have.
Well, the worst epidemic which we're in the grip of very much so at the moment is HIV. And the number of people infected with HIV is about 45 to 50 million people. But up against 6.3 billion people, which is a growth in the last 100 years of many, many-fold, then it still pales into insignificance. But you're right, things like HIV can make a big difference. And these epidemics, which traditionally did sweep around the world and wipe out lots of people, we're getting much better at treating them, which means that the devastating impact they would have had on mankind is becoming less as time goes on.
Right, OK, thank you, Dr. Chris. And it's Sue Marchant, Dr. Dave and Dr. Chris. Dr. Chris, I think this one is more for you. Anne says some people have different coloured eyes, David Bowie for one. How does this happen?
Right, well, in some cases, this is because of an accident, and I mean a physical accident, because normally your eyes are controlled by genes. You have about 5 or 6 genes which, working in a kind of production line, produce pigments which affect the colour of your eyes. And if you have blue eyes, that means there's no pigment. If you have brown eyes or any variation between blue and brown, that means there's some pigment being made. So you need this metabolic production line to be working in order to make these pigments. And people who have blue eyes have defects in the metabolic production line at every single stage. So it's a bit like the conveyor belt doesn't work, the crane doesn't work, the person who picks off the defective things doesn't work, so you end up with blue eyes. And that's why blue eyes are quite unusual, because it's quite hard to do that, because there are lots of ways of restoring that chemical production line to get colour back into your eyes. So that's why blue eyes are what are called recessive, and they're also in the minority. To have one eye that's one colour. I mean, I've got blue eyes, so I'm in the minority. Yeah. But to have one eye that's one colour and one eye that's another is a bit difficult according to that model, because when we're growing inside our mothers, you inherit the genes that you have in every cell in your body from. Half of them from your father and half from your mother. So every cell in your body when you start off life ought to have the same cocktail of genes in it. So it's quite difficult to envisage how you can have one set of genes that are working in one eye, but then just a short distance away in the other eye, they've totally changed their genetic expression pattern and they're doing something different. So a common reason that people have a blue eye and a brown eye is because there's been some kind of injury or damage to the eye that looks brown, and that's why it ends up looking a different colour. In terms of other people having a blue eye and a brown eye, there are genetic possibilities as to how this can happen. There's a thing called mosaicism, and this is where you have slightly different genes turned on in one tissue compared to another tissue, and there's various genetic reasons why that can happen. But this could also explain eyes being different colours or bits of an eye being different colours, because I know of someone who has blue eyes, but in one bit of the iris of one eye she has a segment that's brown. So that must be certain genes that are turned on there that are not turned on in the rest of the tissues. So the answer is very unusual, but it's probably a genetic trick when it does happen.
Dave and I gazing into each other's eyes now, looking to see.
Dave's got blue eyes. I know Dave's got blue eyes.
Yeah, I know. That's
I think you've got blue eyes.
I have. Yes.
So that's three of us who are blue-eyed.
Yeah,
it's quite unusual.
All right. Now another one here. Derek on the road says he's on antibiotics and quite likes to have a beer every now and then. Is it possible for him to drink in moderation while on these antibiotics?
Yes, there's only one antibiotic that, in fact, is bad for you when you mix it with alcohol, and that's one called metronidazole. And you get given metronidazole to kill bacterial infections called anaerobes. And anaerobes are bacterial infections that can't stand oxygen. And there's certain types of bugs that live in your gut. And C. diff, which is Clostridium difficile, one of these hospital-acquired infections that we've heard a lot about in the news recently, that's an example of a bacterium that doesn't like oxygen. It's an anaerobe. But that's the only antibiotic I can think of that actually reacts badly with alcohol. So you should be okay on pretty much everything else. But remember that certain antibiotics are broken down by the liver. If you drink a lot, the alcohol can make the liver break down drugs more quickly, and therefore the antibiotics might not last in the body for as long as they should, and this could be bad. So I think the bottom line is modest drinking, careful drinking of small amounts with anything other than metronidazole is probably okay.
Right, OK, thank you for that. A question here on the text from KJ. He says, "Hi Sue, please could you ask the doctors, is there a best time to walk my dog? I exercise in the morning or afternoon, which is better, I think, for both he and the dog?"
It's a difficult one, that, isn't it? I think there are different types of people in the population. There are people that are larks and there are people that are night owls. And it all comes down to a certain pattern of genes that you inherit from your parents, because in every single one of us we have a body clock. It's the thing that makes us get up in the morning, it's the thing that makes you feel tired at night, and it's the thing that makes you feel jet-lagged when you hop on Squeezy Jet or whatever and go over to a foreign country. And what this body clock consists of is a pattern of nerve cells written into your brain which run a genetic program, and they effectively create the genetic equivalent of a domino effect, where one gene turns on another one, and this turns on another one, which turns off the first one, and this goes round in circles, taking about 24 hours to do it. Now, this means that depending upon how well your clock works, then you might perform better at night or perform better in the morning. And there are different forms of these genes which have slight genetic letters changed in them that make some people function better at night and some people function better in the morning. That's the difference between a night owl and a lark. And the gene is imaginatively called clock, and people have found changes in it which go along with those two types of behaviour. So I think to get the best benefit from exercise, you need to be doing it when you're enjoying it and when you'll do it regularly. But I don't think, physiologically speaking, unless you're having to stay up very, very late at night to walk your dog against your will, I don't think there's any benefit to doing it at any specific time. You do it when you feel comfortable, because the one thing that we have found is that the exercise is what's really good for you.
And for dogs as well, they just love to go out any time. Mine does anyway. OK. Thank you for that.
Dogs by rights are nocturnal, aren't they? So they really want to be getting up at night and hunting and things. So it's a bit unnatural for them to be sleeping during the night time, because they really want to get up at night and do stuff.
Yeah, they're probably like most hunters. They're not very, more sort of at dusk and dawn they're very active, because that's the time when hunters with big eyes have got the biggest advantage over their prey. So if it's pitch black, no one can see anything. But if it's kind of in the sort of dusk dawn sort of time, then they've got the biggest advantage, because they can just see slightly better than their prey and they actually catch them, I think.
Right, one here. Dr. Dave, why is it when a plane breaks through the sound barrier it roars loudly as if it's going to crash into your house?
It's not actually as it goes through the sound barrier. It's any plane which is going faster than the speed of sound will create what's called the sonic boom, which is that thump which you can feel as a supersonic plane goes over you. Normally it's actually two thumps very close together. I used to live in Devon, and you could hear that when Concorde went past, going faster than the speed of sound down the channel, you get two thumps which would rattle the windows. It's actually very like a bow wave from a boat. So because the plane's going faster than the speed of sound, the air doesn't have time to get out of the way, so it sort of piles up in front of it, and this forms a wave. And that wave kind of travels out from the plane, just like a bow wave from a boat. And then when this bow wave passes you, then you hear a thump, because it's this big shock of air pushing you. So you hear a thump. If it's very, very close, it'll probably actually shake you. And someone further down the road will get that thump slightly later than you, or slightly earlier if they're further up the road.
Right, we've got a caller on the line, and it is Tony.
Good evening, Sue.
Hello there.
I was listening to a very interesting programme on telly the other night about the Earth and all that sort of thing, and it mentioned something about another Earth, billions of years ago, crashed into our Earth, and in a nutshell, and created the Moon. Now, is there anything about that? Is it true?
Yes, that is actually that's the theory which people reckon has created the Earth and the Moon system as it is at the moment. Compared to all the other planets in the solar system, the Moon compared to the Earth is very, very large, except possibly from Pluto, and it's quite close to the Earth for its size, and very tightly bound. And so people have been trying to work out how you get this sort of configuration of a planet and a very large moon going around it. And the way that they think it happened was the Earth was originally about 2/3 of its present size, a bit smaller. Then you got something about a third of the size of the Earth, or about the size of Mars, and crashed into it just sort of off-centre. And so as it crashed into it, it spun the Earth very, very fast. And this threw out, in the impact, it threw out lots and lots of globules of molten rock into the sort of surrounding area. And those slowly, some of them sort of rained back down on the Earth, and some of them coalesced to form the Moon. And this is why the Moon is actually much less dense than the Earth, because it was all the light stuff on the surface which got thrown out. And it also means there's a reason why the Earth is a bit more dense than most of the other planets, because it was tended to be the core of both the two smaller planets that ended up coalescing to form the Earth. And then the Moon started off much closer to the Earth than it is now, and then the Earth was spinning much faster, and then the tides slowed down the Earth and sped up the Moon, and the Moon slowly moved out to the distance it is at the moment.
Oh, that's terrific. Is the Moon solid, or is it molten in the middle?
I think the present theory, I think it's solid in the middle. It's much smaller than the Earth, so it's cooled down much quicker.
That's jolly interesting. One other little thing. We can drill a hole right through to France, okay?
Yeah.
Why can't we drill down to our molten and use that for
energy? It is something which people have actually tried. The problem is that where we're sitting now, to actually get down to the molten rock, you'd probably have to drill sort of at least 10 kilometres downwards.
Kilometres, my God.
Which is an awful lot of rock to drill through. You probably wouldn't have to drill quite that deep to get something hot enough to be useful. I think they were doing a small project in Cornwall where they were drilling down maybe 2 or 3 kilometres through granite, and because granite's radioactive, it acts like a big, very slow nuclear reactor. And it heats up, and they were getting some useful energy out. The problem is it's just too expensive to drill the holes.
I mean, it's not half as far as going to France. We've got such huge, great things now, haven't we, Dr. Dave, to do this. More likely than, say, 100 years ago.
I mean, it's all about economics. Partly when they're going through France, you're not really drilling through very, very hard rock because you're sort of going, mostly it's through mud and soft chalks. Whereas if you went down, you'd end up in quite hard rocks. But if you live on Iceland, that's a wonderful form of getting power because you're right where two plates join. There's lots of molten rock coming up, so it's very close to the surface. Yeah. So, in fact, Iceland is the biggest producer of bananas in Europe because they have greenhouses heated by the molten rock growing bananas.
Oh, well, thank you very much.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye.
Bye. And some more questions coming up. Let's find out from Fiona, who listens in Norwich. She's wondering which is colder, the North or the South Pole, and why?
The South Pole is quite a lot colder than the North Pole.
Really?
Yeah. The lowest temperature ever was, I think, recorded somewhere in South Africa, not in South Africa, in the South Antarctica. It's about sort of minus 80, even minus 90 degrees centigrade, whereas the North Pole will get down to minus 40, minus 50, but quite rarely. There's a couple of reasons for this. One of them is that the South Pole has got a whole lot of big mountains on it and a whole lot of ice on top of the mountains. Mm-hmm. So the highest parts of the South Pole are maybe 2 kilometres up. As you go up a mountain, it gets colder. So if there was a 2 kilometre mountain on the North Pole, it would be quite a lot colder than it is now because you've just gone up higher. And the other thing is that the South Pole, it's a circular continent surrounded by sea, whereas the North Pole is a sea with continents coming up into it, a bit like paddles, which means you can get ocean currents moving up from the warmer latitudes further south up to right the way up to the North Pole. And now water, it contains a huge amount of heat, so even quite a slow, small ocean current will move a lot of heat up to the North Pole. So even though it's minus 4, even though maybe it should be minus 70, minus 80 degrees centigrade, because of all of this heat moving up with the water, it's kept relatively warm compared to what it should be. Whereas the South Pole, it's insulated because the water can't get very close to it. So there's nothing to stop it getting really, really, really cold in the middle of winter, right down to minus 80, minus 90 degrees centigrade.
Crikey. That is really cold.
Both of them, they can get down to a temperature where you can take a bucket of boiling water and throw it up into the air, and by the time it hits the ground, it's frozen.
That's amazing, yeah. But you'd have to get your gloves on, though, wouldn't you? Now, I saw this little Prezi for Stanley Dog, and today I found this brush. I haven't brought it in, obviously, because health and safety in the studio can't be, but it's a pet brush. It has a battery in it, and it says it gives out ions, and that's going to help him smell better and cleanse his coat easier. What's an ion, and how is it going to do it?
I can certainly tell you what an ion is. Mm-hmm. Basically, if you've got an atom or a molecule, normally it's got no charge. It's got the same number of positive bits, the little protons inside the atoms, as negative bits, the electrons outside it. So it's neutral. It won't be attracted to charges very much. It just sit there. It's fairly boring. If you rip off some electrons, then it will become either rip off electrons or give it some extra ones. It will become charged. I mean, it'll be positive or negative, and that's what an ion is. If you pass electricity through air, so if you get a spark, the electric current is actually being passed by these ions moving through the air. And they move through it and they heat things up a lot, so you get this really bright blue spark. In fact, there's quite a lot of the light given off is by the electrons bouncing back in, being caught by the atoms again, or the molecules again, and that releases lots of energy, which is given off as light. Now, quite why these ions should be deodorising things, I'm not sure. I'm slightly suspicious, although I don't really have any knowledge of it. It's possible. I mean, ions can be quite reactive, so it could be just killing things if you had enough of them. I'd be surprised if you could make enough of them with a little battery.
Yeah, it's a little 5-volt battery, one of the little square ones. Yeah. And you put it on, and this little light came on, and I thought it might vibrate or something, or it might buzz. But no. And I thought, and I switched it on, and started brushing Stanley Dog, and he was quite happy with it. And I thought, I mean, why did I expect it to do something with that, you see?
You can make ions by putting something at very high voltage, and if you've got a sharp point at a high voltage, you will get ions formed, and they'll actually then get repelled from the high voltage, and you get a wind coming off it. The ions would be quite reactive. They're probably going to damage things which they hit, so they might kill bacteria on the surface.
Right.
But I'd be surprised if you could make I'd be very surprised if you could do that with a little tiny battery and
right. Well, he likes it anyway.
Well, as long as he enjoys it, then that's good.
Absolutely. So that's one of those things. It's very often when we buy something, someone's been round the gadget fair and one thing or another. We have it because it's a kind of, we're obviously obsessed with it, and we don't really understand how it works. The other thing as well that I noticed when I went shopping, I got sucked into this dress shop because they had a sale on. Yeah, because I haven't been out since I worked all over the place. And very often when you buy something that's chiffon or, there just seems to be a lot of static and a lovely dress and everything. And I thought, that's all right. What's it going to be like, once I've got my sort of stage shoes on and bits and pieces? Am I going to get a lot of static everywhere? Because one doesn't want it hanging round the body and that
tends to cling.
Yes, cling. One doesn't want to be over-clinged. So I just wondered, why are we getting so much static with this stuff?
Static electricity is to do with these charges moving again. If you've got two different materials and touch them together, so if you touch something like rubber and hair, the rubber likes the electrons much more than the hair does. You get a few electrons passing from one hair to the rubber. Then if you touch lots and lots of different hairs in lots of different places, you can move quite a lot of charge to the balloon and it will charge up. Right. And it will attract other things, like you can stick it to the ceiling.
Yes.
It's done that.
Yeah.
And it will attract the hair really nicely. And the same thing's probably happening with the dresses. If you've got something with a very artificial fibres, especially nylon's very, very good for it, they will attract electrons very strongly. And if it's very close to something, a more natural fibre, especially wool or your own hair, that they'll give the electrons away. So that if you put a nylon jumper over your head, you'll charge up the jumper to be quite negative, and your hair will go quite positive. And then sometimes that charge can build up so much it will jump back to you through the air, forming a spark. The electricity flowing through the air, and it can actually hurt quite a lot.
I know. And you hear it goes.
There's actually little tiny explosions because as the current goes through the air, it gets very, very hot. That expands and that shakes the air, which you can hear as a little click.
How can we get rid of it on our clothes?
I don't know whether you can get some material. If you can make them slightly conductive, then the electric charge will conduct away through you to Earth and it won't build up, which is why it tends to be much less of a problem on very damp days.
Yes.
So if you go to a very hot, steamy room, then because electricity can flow through damp air much better than dry air, and especially along damp surfaces, then it will just kind of dissipate gently of its own accord, and you won't charge up, and your clothes won't charge up either.
So just go out in the rain?
Go out in the rain, you won't have any problem with static at all.
Fine,
it's a great problem if you're trying to do static experiments.
Thank you for that. See, science solved easily here. Carla sent one in. How do you get petrol, diesel and ethanol from crude oil? What's the process?
Petrol and diesel are very easy to make from crude oil. Crude oil is the remnants. If you take plants and animals, you bury them really, really deep, you cook them. They get heated up, but as they get buried deep, they get heated up, and then as they kind of get mushed up and kind of cooked, and they turn into a black gunge. And this black gunge is an oil. Water gets driven off by the heat. It's lighter than water. It'll float upwards until it gets caught by some waterproof rocks, and then you can drill down and collect it out of. Especially if you've got some nice sandy rocks underneath that, like a sponge, and you can suck it out of the sponge, and you can get the crude oil out. This is the really important stuff, which is our whole economy is based on crushed up, cooked ancient animal remains. And this is a mixture of all sorts of different things.
Right.
Most of it are hydrocarbons, so things with carbon and hydrogen in them, and that's what petrol and diesel are. You can get petrol and diesel just by heating up the crude oil. Different bits will boil off at different temperatures. You just pick the ones which are boiling off at the right temperature. Petrol will boil at a lower temperature than diesel, so that will get boiled off first, and then at a slightly higher temperature diesel will get boiled off. Then you can, with a bit of purification, you can put them straight in the car and they'll work fine. You can actually make petrol from things with even higher boiling points by sort of chopping them up and making them back into petrol, so that can be quite useful as well. Ethanol you can also make from crude oil. That's a slightly more complicated process. You've got to take the crude oil, some of the long chains in it, then just cook it really, really hot, and that makes a gas called ethene. And then you react that with water, which forms ethanol, and which you could drink if you wanted to, but I think you'd have to be quite brave because there's tend to be other chemicals in the stuff made from crude oil, if you're not careful, so it's probably best to stick to the stuff which has been brewed.
Yes, I would say so, or make chips in it or something like that. Yeah. Right, let's get on to DAB radio, shall we? John in Peterborough, DAB radios consume quite a bit of power. How does this compare to the old valve radios?
I would have thought that valve radios are probably going to use more power than a DAB radio, because a valve, it's used to make a small electrical signal into a more powerful one. The way they work is by having a little coil in them. Basically, it's a light bulb. You heat up this little coil to get very, very hot. You then charge it up to quite a high voltage, and so a current will flow from it to the other side, and you can connect that to your loudspeaker, and you'll get a signal out. And you use another weak current and weak voltage next to it, which kind of deflects that beam and stops the current passing, so you can turn it on and off. So a very small change in the weak signal can turn to a big change on the output into your loudspeaker. But you've got to heat up this filament. So basically, inside every valve radio, you've got several light bulbs running. And I think that each one of those is going to be getting on for nearly as much power as a digital radio would use. Definitely the one I've had recently uses about 5 or 6 watts. And you can get little handheld ones which will run off a battery, so probably use considerably less than that. So I think a DAB radio is probably better than a valve radio. But it's an awful lot. But we've had 50 years to improve the technology, so you'd hope so.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.